Good morning to You Can Do It Maths. Today we're doing the May-June 2021 paper 41 extended. We're going to have fun. Question 1A. The total cost of a taxi journey is calculated as 50 cents per kilometer, 40 cents per minute. Calculate the total cost of a journey of 32 kilometers. That takes 30 minutes. Right, so easy stuff. Kilometers is 0.50 times 32. Okay, which will give us $16. And then the minutes is 0.4 times 30, which will give us $12. Add them together, $28. Total cost of a journey of 100 kilometers is $98. Show that the time taken is 2 hours. So let's start with the 100 kilometers. So if it is $0.5 per 100 kilometers, that will give us $50. Okay, show the working out here. It's important to show everything. That means if we subtract the $50 from 98, we get 48. So that's how much was being paid for the time. So we need to do the previous calculation here backwards, which means it's $48 divided by 0.4, okay, which will give us, of course, 120 minutes. Then just show 120 minutes equals 2 hours. Okay, all working out is shown. That is very important. Question 1b. 3 taxi drivers travel a total of 8,190 kilometers in the ratio 5 to 2 to 7. Calculate the distance each travel. Right, so let's just think about this. If taxi driver number 1 travels 5 kilometers, taxi driver number 2 only travels 2. He's the lazy one. And the third one travels 7 kilometers. He's the hardworking one. All right, that means in total, they would have traveled 14 kilometers. Okay. Only difference is they did not travel 14 kilometers. They traveled 8,190 kilometers. So we need to keep adding up the distance each one travels. 5 plus 2 plus 7, 5 plus 2 plus 7, until we get 8,190 kilometers. Or the quicker way of doing that is dividing it by 14. 8,119 divided by 14. 585 times. We need to keep adding this up. Okay. That means for the first driver, that will be 5 times 585, which is 2,925 kilometers. For the second driver, it will be 2 times 585, which is 1,170. And the last one, of course, 7 times 585 is 4,095. Take a few seconds just to add up those numbers. Okay, you don't have to show this, but you do this with your calculator. Add these up to make sure you've done it right. So 2925 plus 1170 plus 4095, and it adds up to 8190, which it should be, and then you know you've got it right. Okay, take a few seconds, check your answers. Question C. After midnight, the cost of any taxi journey increases by 45%. Now remember, an increase of 45% means we take the original amount, which is 100%, we add 45% to that, which means we end up with 145%. As a decimal is 1.45. That is our multiplier. So whatever we do, we work with 1.45 or 145%. Okay. Our journey costs $84.10 after midnight. calculate the cost of the same journey before midnight. We need to recognize here that we're working back in time. Okay, we're working backwards. So where we would have multiplied, we're now going to divide. Let me show you what this means, right? There is the cost, the original cost of a taxi journey. Let's write that as the original cost. If we take that cost and we multiply it by the multiplier at 1.45, it means we increase it by 45%. We will end up with the answer that they've given us, $84.10. We're now working backwards to get the original cost, the cost before midnight. So that means to get that original cost, we're going to have to divide, okay, by 1.45. So let's do that. 84.1 divided by 1.45, $58. Does this make sense? Yes, because we're working out the cheaper price before midnight, so it has to be less. It can't be more. Question 2. Speed time graph. It shows us the first 180 seconds of a journey. First one, find the acceleration. Remember, speed time acceleration is the same as the gradient over that period. There's a lot of information hidden in the units like this. You see that's meters per second squared. Now, to work out the gradient, if you remember correctly, it is the rise over the run. So how much the change in y over how much the changes in x. Now, the change in y, the vertical distance there, is 9 meters per second. And the change in y here is from 0 to 50, so that's 50 seconds. You see that? 9 over 50 meters per second. That 2 seconds will give us second squared. And that's the answer. 9 over 50 is perfectly reasonable answer. If you want to write it as a decimal, 0.18 is also correct. Either one will do. Question 2b. After 180 seconds, the train decelerates, slows down at a constant rate of 1,944 kilometers per hour squared. Show that the train decelerates for 60 seconds. You see that kilometers per hour squared is in bold. And so when something is bold, you know, pay attention. And the reason it's in bold this time is because we are working in meters per second. They give it in kilometers per hour, so we need to change that to meters per second. So this goes by this slowly, step by step. Let's first change kilometers to meters. Now remember, if you want to change kilometers to meters, you need to times it by, kilo means 1,000. So we're going to do 1,944 times 1,000. So we just bang 3 zeros at the end. And we now have meters per hour squared. Okay, now we need to change the hours to seconds. So how many seconds in an hour? Well, there's 60 seconds in a minute and 60 minutes in an hour. So that gives us 3,600 seconds in an hour. Now that 8 hour square is division below the line. Okay, so we're going to have to do 1,944,000 divided by 3,600 seconds. Remember, this is deceleration. There's a square, so we square that 3,600. So let's have a go with that. 1,944, 123, divided by 3,600 square gives us 0.15 meters per second square. We are now. That's the deceleration. Okay. How do we get the 60 seconds though? Okay, the answer is still there in our units. So if we need to get rid of the meters and one of the seconds, so we have just seconds left. So let's see, it decelerates here over a period of 60 seconds and it starts at a speed of 9 meters per second. Okay, so what's going to happen now, if we take 9 meters per second, divide that by 0, make a nice 0, 1.5 meters per second square, we'll be left with just the time, which will give us 60 seconds. And you've got it. Question 2C, complete the speed time graph. Take your ruler and your pencil. We know now it starts decelerating over here, which is 180 seconds. It decelerates for 20 seconds, so for 60 seconds. So there at 240 seconds, it comes to a standstill. So we get our ruler on there and draw a nice straight line. And you got your marks. Okay. Question 2D, calculate the average speed of the train for the whole journey. Now remember this, in a speed time graph, distance traveled is the area underneath the graph. So we need to work out all the area here. Now, what most students do is they break this up into 2 triangles and a rectangle and work each one separately, 3 calculations added together. That works. Nothing wrong with that. You can get your correct marks doing that. But reading the examiner's report, students who did it that way made lots of small mistakes and they lost marks. The most successful students is the ones that saw this as a trapezium and worked it through one calculation as a trapezium. Now remember, the formula for the area of a trapezium, that's a trapezium, yeah, is half a plus b times h. A plus b being the 2 parallel sides. So in this case, with our trapezium here, it will be this distance from 50 to 180, which is 130, and the distance at the bottom from 0 to 240, which is 240. Okay, so we start with that. It's a half, or was it 130, right, plus 240, so 2 parallel sides, times the height, and over here the height is the speed after when it's full speed, which was 9. Perpendicular height is 9. So all we need to do is put that into our calculator. And then we get a answer of 1,665. And what is this? This is the distance traveled. So that would be meters. Okay, we're going for the average speed. So if we travel 1,665 meters, and we're traveling this in 240 seconds. Remember how we work out speed. It's speed, distance, time. So we need to take the distance, 1,665, and divided by the time, 240 seconds is the total traveling time. That's when we get the correct answer of 6.9375. And then if you round it to 3 significant figures, 6.94 meters per second. Okay, the mark scheme, they don't show the answer to 3 significant figures. They only show this answer up here. But I mean, if you give both the full answer and the rounded answer to 3 significant figures, they got no reason not to give you full marks. Question 3a. It's very important in questions like this to pay attention to every detail. Every word counts. So let's go through the information they give us. So there's a diagram that shows a solid cone and a solid hemisphere. The cone has a radius of 2.4, we can see that, and a slant height of 6.3, we can see that. The hemisphere has a radius of r, we don't have. Then the total, you see that's in bold, So immediately that should pop out of you. So this is something important. Total surface area of the cone is equal to the total, again, surface area of the hemisphere. Calculate the value of R. Right, it's a lot there. It seems difficult. Let's just start with what we got. We got this formula here, which is the curved surface area. Okay, look at this different. Curved, total, total, curved, curved, total, total, curved. That's where one of the biggest problems lies. Reading the examiner's report, that's where the most mistakes came in. This difference between curved and total. So let's start with the cone. Start with the cone. Okay, and we know the area of the cone, surface area, is pi RL. So pi, the R is the radius, which is 2.4. They've given that to us. The L is the slant height, which they've given to us. The slant height, that's 6.3. Okay, we can hammer that into a calculator, just like that. Plus 6.3. Okay, and it gives us an answer. That's a pi multiply, and that's the decimal answer, which is quite big. Okay, but that only gives us the curved surface area. So remember, to this, we need to add the parts that not the curve, which is the base. So to get the total surface area, we need to add the base to the curved part, which is the top part. And remember, the area of a circle is pi r squared. Just write that down. Remember, that's pi r squared. So pi radius is 2.4 squared. So to the answer we have here, we add another pi times 2.4 squared. Okay, and that gives us the total surface area of the cone. Now we can write this answer 65.59645, as long as you don't round it yet. We only round at the end. So for me, the most accurate answer is this one in pi form. Yeah, 522 over 25 pi. That is just the most accurate unrounded answer. So we have the best answer in the end. So we got the cone. Let's now do the hemisphere. Okay, and there we got that. The area of the hemisphere is 4 pi radius, which they've given us as a big R. So let's put that big R in there. Okay, again, look carefully. This is the curved surface area, yeah, which is the bottom part here, of a sphere. You see what's missing there? Detail, the hemi. So that's the whole ball. We only have half the ball, so we're going to have to divide our answer here by 2. And that will give us a curved part. But again, we got this whole chunk there, right? The circle, which again is pi r squared, which we need to add on for the total surface area. So we're going to have to add that again. Pi r squared, in this case, the radius is a big R squared. Okay, and what does it equal to? It equals to our previous answer, because that's what they said in this sentence, that they are equal, the two answers. So that equals to 522 over 25 pi. Okay. Now, what we need to do to find R is we need to solve this massive equation. Now, it's easier than it looks. Let's start over here. 4 pi R squared divided by 2. We can just divide that, 4 by 2, which will give us 2 pi R squared plus pi R squared equals this whole massive story over there. Okay. Now, basic algebra, we can add these two terms together because they are the same. Pi r squared is the same. So it's 2 pi r squared plus another 1 pi r squared gives us 3 pi r squared, which is equal to everything over here. Okay. Now, next thing, let's get rid of this 3 pi. This is 3 pi times r squared. So what we can do is we can divide both sides by 3 pi. So in the end, it's going to look like this. Our whole answer over there divided by 3 pi. Now I still have my previous answer on the calculator there, so all I have to do is to divide by 3 pi, and bam, I got a really nice looking answer there. It doesn't have a massive amount of decimals, 6.96. Last step, square root that 6.96. Square root previous answer equal, and there we go, 2.6381, etc. So write a bunch of digits, which when we round it to 3 significant figures is 2.64. You can do it. Question 3b, once again, pay attention to detail and read all the information. So let's do that. The diagram shows a solid cone with a radius of 7.6 centimeters. Yes, we can see that. And a height of 16. Yeah, that's clear. A cut is made parallel to the base of the cone and the top section is removed. We can see it there on the right. Yes. The remaining solid has a height of 12 centimeters. Yep, we see that. As shown in the diagram, calculate the volume of the remaining solid. Right, so let's start by working out the volume of the big cone on the left, which is using a formula they've given us, a third pi, radius, given that to us, 7.6 squared, and the height they've given that to us is 16. This is straightforward. Let's hammer that into our calculator. 1/3 by 7.6 squared and 16. There we go. Now, there's the answer. Loads of decimals there to write down. Most important thing here is don't round your answer. Never round until the very end. So if you want to be 100% accurate, this is the best version to use. 2310/75 pi. That is a very accurate answer in terms of pi. Right, next thing now, obviously, we need to subtract that little cone that was removed. That's very clear. So let's see what information we have of that little cone. Okay, so if there's a little cone here that we cut away, okay, what do we know about this cone? Well, first thing is 16 centimeters. There's 12 centimeters remained of that, so the height of the cone will be 4 centimeters. But what is the radius? What is the radius? Okay, best way to do this is to look at this in terms of similar triangles. On the left here, we got a triangle with a base of 7.6 and a height of 16. Over here, on the right, small cone, I'm just going to draw that triangle again. Okay, we got a similar triangle, which means it's the same, it's just smaller, with a height of 4. But what is the base? Or base rather is the radius. Okay, now it's very clear to see that this similar triangle is exactly 1/4 of the original. 16 divided by 4 gives us 4. That means to get the base or the radius of this triangle here, we need to do 7.6 divided by 4, and that will give us 1.9. And now we got the radius, 1.9. So we can now go ahead and work out the volume of the smaller cone that has been cut away. It's got a radius of 1.9. We square that, and it's got the height of 4. So let's put that into a calculator. Okay, and again, you can write down all these digits to be accurate, or the most accurate here will be 361/75 pi. That is just the answer in terms of pi. Okay, so last step to do now, we subtract the one from the other, and that'll give us the volume of the remaining solid. So let's write that down. Pi minus 361/75 pi. Let's see what that gives us. Okay, so 23104 over 75 by subtract. If you press the answer button, it inserts the previous answer, which was the one we had, and bam, gives us a very accurate answer. And now we can write down the digits because that's what they want. 952.656, etc. And that's the most accurate answer, rounded to 3 significant figures, 953 centimeters cubed. You can do it. Question 4a. The exchange rate is €1 equals $1.142. Johann changes $500 into euros. Calculate the number of euros Johann receives. Give your answer correct to the nearest euros. So let's write this down. €1 equals $1.142. Johann has $500. What is the euros? How do we get from there to there? What do we multiply it by? Okay, let's do the inverse calculation. 500 divided by 1.142. 500, 1.142 equals 437.828, etc. So we turned $1.142 into $500, so we need to do the same here. We need to multiply that by 437, etc. So we got the answer, 437, rounded to 3 significant figures. Well, in this case, you have to round it to 3 significant figures because they want the answer to the nearest euro. So if you don't write 438, you don't get full marks. Question 4a, part 2. Johann buys a computer for $328. The same computer costs €275. Calculate the difference cost in dollars. So now we change that €275 to dollars. That's all we need to do. So let's write this down again. Remember, €1 was $1.142. Now it's the euros turn. We've changed €1 to 275 euros. So we're going from there to there. How do you get from there to there? You multiply it by 275. So you have to do the same here. We need to multiply that by 275 to get the answer. So 1.142 times 275, and we got the answer in dollars, $314.05. Okay, but the question is, what is the difference in cost? So the one in dollars was more expensive, 329. Subtract the ones in Europe and euros. Europe is cheaper. So let's do that. 329 minus, put our previous answer in there, and we get $14.95. Okay, they don't ask us to round it, and it's money, so best to write it to 2 decimal places. Okay, now comes Lucy. Right, spends 3/8 of her money she has saved this month on a book that cost $5.25. Calculate how much money Lucy has saved this month. Let's think of this in terms of pizza. There's a pizza. We are going to divide this pizza into 8 parts. There we go. We've divided this pizza into 8 parts. And this $5.25 amounts to 3/8 of the pizza. So this here, in terms of pizza money, is $5.25. We want to know how big the whole pizza is. So the first thing we can do, we can take this $5.25 and divide it by 3. Then we'll know how much is one slice. Okay, let's do that. 1.25 divided by 3. No, divide by 3. Okay, 175. That's 175 for the pizza. One slice of pizza. Of course, the whole pizza is 8 out of 8 slices. So if we got the price of 1/8, to get the whole thing, we need to multiply it by 8. So the next step is 175 times 8. And that gives us $14, which makes sense. People like to save money to the nearest dollar, which is beautiful. Right. Where are we now? Question 4C. Now we got Kamal invest $6,130 at a rate of R% per year, compound interest. The value of his investments at the end of the 5 years is a very weird $66,669. Calculate the rate. So remember this formula. Let's see if we can get it in focus. There we go. That's what we need to use. Okay. So the amount you'll have at the end of whichever time is equal to the principal, which is the original amount, times 1 plus the rate divided by 100 to the power of n, which is the amount of time. So the amount we have at the end of the time, they've given that to us, which is $6,669. The principal, the amount we start off with, is 6,130. R is the one we don't have, so we leave it at that. And it was a time of 5 years. So we need to solve this to find out what's R. We start as far away from the unknown as possible. And remember bitness. Right, so before we work out the power, the index, we need to do the multiplication first. So we need to get rid of the 6,130. So we need to divide both sides by 6,130. So that will be left 1 plus R over 100 to the power of 5. So let's do that. 6,669 divided by. Okay. Oh, that's funny. Now, we're not going to be writing all of those digits down. Okay. So the best is just to leave it the way it is. That seems to be the simplest fraction, simplest form it is in. Next step, get rid of that power 5, the index 5. So to do that, we need to do root 5. So we will do root 5, all of this. We'll leave us with 1 plus R over 100. So let's do that. To do that, we do shift and this button here, which now allows us to put in the little 5 there. And inside there, I want to put my previous answer, which is 6,669 over 6,130 equals, and we get that beautiful looking 1.0169997. That should be enough decimals to be accurate. Equals to 1 plus R over 100. Next step will be to get rid of that 1. So let's subtract 1 from both sides. So we just minus 1. That gives us 0.016997 equals R over 100. And to get rid of the 100, we multiply the 100. And we got our rate, interest rate, which is 1.6997, etc. Rounded to 3 significant figures, which means we cut it off there. That will give us 1 point after 69 comes 70. Right, percent. Good to put in the percent. You don't have to put the percent. Okay, that is a very modern, reasonable interest rate these days. Question 5, we've got triangles. We got angles, we got sides. We know it's got to be trigonometry. If we had right angle triangles, we know we could use Pythagoras if we're working with the side lengths, or if there's angles involved, we use SOHCAHTOA. But we don't have right angle triangles here. That means we are either going to use the sine rule, all right, or the cosine rule. Or if it's area, half A, B, sin C. So let's look at the first question. Okay, they give us a lot of information, which we can see there. Calculate AC. So AC over here is in triangle AXC. What do we have in triangle AXC? We got 6.4 centimeters. We get 10.6 centimeters. And yes, we can work out this angle over there by simply doing 180 minus 78, which will give us 102. So which rule to use? Okay, in this case, we use the sine rule. Sine rule is helpful when we want to know a side, and we have the opposite angle and the two sides next to it. Okay, so let's write down the sine rule, cosine rule. Right, yeah, cosine rule. A squared equals B squared plus C squared. You recognize Pythagoras in there. And then it's simply 2BC cos A. Now, very rarely your triangles is going to be labeled the way you want it. So we're going to label it ourselves, right? We're going to change how it's labeled, as I say. So the side AC want to know, we can label that A, which makes the opposite angle here our big A. Then B and C doesn't matter which way around it is. But since we already have a C here, we can make that a small c, and we can relabel this side here, XC, as the small b. So it means things are going to look like this. A squared will be the side we want to know, which is AC. B is 6.4 squared plus C, 10.6 squared. Once again, if you swap these two around, 6.4 and 10.6, it doesn't matter. You'll still get the right answer. Then it's 2. Again, B and C got cos A, which we relabeled as 102. Okay. Quickest, best thing to do here is type everything in your calculator straight away. That means to get off this square, we're going to have to square root everything later on. So if I can do that right from the start, it would speed things up. So in the end, to find AC, we just need to key that into our calculator. So it's the square root of 6.4 squared plus 10.6 squared minus 2, 6.4, 10.6. Make sure you press the right buttons. And then we got cos 102 close bracket equals, and we get an answer there, right, which is 13.4732, etc. Rounded to three significant figures, 13.5. Question 5b, calculate bx. So let's just get rid of a bit of this clutter. We've handed there. Okay, keep the important information. Bx, we want to know this one here. Okay, what do we have? Okay, we've got an angle here, 58, and the opposite sides. The moment you see that, opposites, you need to think about this sine rule. Sine rules got all to do with opposites, right? If you got angle A, opposite side, and you want to work out another side, and you got the angle there, or you want to know the angle, got the side, that's what we're looking for, opposites. So in this case, we're going to use the sine rule. Now there are two versions of the sine rule. Okay, let's just see. The best version to use is to put in the top left hand corner the thing you want to know. In this case, bx. We want to know what is bx, so we're going to put that over there. Bx divided by, let's put the sine rule back in there. Okay, I've now put the side at the top. So there's bx over sin the angle that is opposite that side, which is this angle up there, which we do have. Of course, we can do basic angles in a triangle, which is 180. Let's do it over here. 180 minus the two angles we have, 58 and 78. Speed things up. There we go, 44. We got that angle here. So using the sine rule correctly, that will be sine 44. That is equal to another side we have, which is 10.6. Over sine, and the opposite angle there is 58. The reason I'd like to have the unknown, the thing we want to work at the top left hand corner, is because now the next calculation is a lot more straightforward. To work out bx, we simply multiply the sin 44 on the opposite side. So we look like this: sin 44 times 10.6 divided by sin 58. So straightforward and easy. Put that into our calculator. Over sin 58. We get a beautiful answer there, 8.682, etc. Rounded to three significant figures, 8.68. Question 5c, the area of triangle ABC. So triangle ABC is the whole thing there, the whole big triangle. Now, we would have remembered that the area of a triangle is half base times height, which we don't have. We don't have the perpendicular height, which means then we're going to have to use the other formula of a triangle, which is half AB sin C. Now that means in a triangle we need two sides and the angle in between, which we don't have for the big triangle ABC, but we do have it for the smaller triangle here, for example. So half AB sin C means half the two sides we have and the angle between those two sides. So it's going to look like this. Okay, let's write this. Let's say the area of triangle, let's call it triangle 1, is half A being any one of these two sides. Let's make it 8.68. 8.68 times the other side in that triangle, 10.6. And then that multiplied to sin, and the angle between the two sides, 10.6, 8.6 is 78 degrees. So let's hammer that into our calculator. Half 8.68, 10.6, sin 78. Bam, we got one answer, which is 44.9987. Put lots of digits, don't round it yet. Okay, so that's the one triangle. Let's go to the other triangle. Let's pick a different color for this one. Nice, purple. So in this triangle here again, we need two sides, and we got that here with 10.6. Got the other side 6.4, and we got the angle between those two sides. So the area of triangle 2 will be half 10.6. Remember, that was the same. The other side was 6.4, and the angle in between was 102. Let's hammer that into our calculator. 1 over 2, 10.6, 6.4, 102 equals, we got the other answer, 33.1787. And all that's left now is to add those two answers together. So let's do it thoroughly. Pick a nice color. There we go. 44.9987 plus 33.1787. What's that going to give us? 78.1774, etc. Rounded to three significant figures, 78.2, and we've done it. Question 6, Venn diagrams. My favorite. I love these things. Let's get right in there. In the Venn diagram, shade the region, the complement of P in union with Q. So we just start. Complement of P means everything that is not P. So let's shade everything that is not P. Shade that nicely. Okay, no overlaps. Use your pencil, turn it sideways. Remember what you learned in primary school. Okay, and we shade it nicely. Don't draw lines. Okay, they want you to do some proper coloring in here. Okay, there we go. That is the complement of P. Then Q, just Q, shade in Q. All right, and then the question is, what now? Okay, what do we do now? And the answer is, this is the union. Union means in the one or the other one or both. So we leave it as it is. Okay, if it was intersection, that one there, we would have only kept the part that they've overlapped, which would have been this part in Q there, this part in Q. Okay, but that's not the answer we want. Okay, we want the one we just had before. Question 6b. There are 50 students in a group, so that immediately means the universal group, everything in that box needs to add up to 50. Remember this. This is important. Okay, then it's 34 have a mobile phone. So in pencil, this is not my answer yet. In this circle for a mobile phone, things has to add up to 34. Okay, I'm writing that in pencil because I'm going to rub it up. 39 have a computer. So in the circle on the right, in the set on the right, needs to add up to 39. 5 have no mobile phone or no computer. That means they need to go inside the box but outside the circle, and that is an answer. And I'm going to put the 5 there. Okay, that means if everything needs to add up to 50 and I've got 5 outside the circles, inside the circles, things need to add up to 45. Okay, but at the moment, they don't add up to 45. We got 34 and we got 39. And when we add those together, what we get 73. That's way too much. Way too much. Doesn't make sense. Okay, should add up to 45. We got 73. That is where the overlap comes in. That means, yeah, how many too much is that? 73 minus 45. What is that? 80, 28. Okay, 28 too many. Those is the people that's got both. Okay, that is the overlap. 28 has got both. Now that we've got that figured out, we can work out the rest. Mobile phones should be 34. We already have 28 in that circle, so that means 6 goes over there. Computers should be 39. We already got 28 in there, so 39 minus 28, that is 11, and that's what it should look like. Rub out your notes so there's no confusion. Double check. Let's see, 6 plus 28 plus 11 plus 5 equals to 50, you know you got it right. Question 6C, still continuing with Venn diagrams. This time it shows 30 students in a group who have brothers, sisters, and cousins. Right? Write down the number of students who have brothers. That's simply everybody that is in the B circle. So 2 plus 2 plus 1 plus 3 is 8. Next question, write down the number of students who have cousins but do not have sisters. So cousins, all of these have got cousins, but the ones that got sisters is this one and those 7. So that will be 3 plus 8, 11. 3 that has brothers and cousins, and 8 who only has cousins. Next one, find n. That n stands for the number. Now in this Venn diagram, they're already showing the numbers. All right, there are 2 people, that's a number. If we had a different kind of Venn diagram where they, for example, showed pets and they wrote the names there, like cats, dog, fish, hamsters, snakes, then you would have to count how many words there are, and that would be the number. But in our Venn diagram, we're already working with just numbers. So it's basically just adding up the numbers. Okay, so let's have a look. We got B in union with S and union with C. So B in union with S and union with C means B, yeah, and S and C. That's all in brackets. With the complement, it means exactly the opposite of that. So that refers to what's outside, which is 2. Okay. Next one. Use set notation. Now set notation is what we have here. That's set notation without the n. To describe the set of students who have both cousins and sisters but do not have brothers. So describe the students who have both cousins and sisters but not brothers. That basically refers to these 7 over here. Okay, I want to show you everything. There you go. Those 7. Okay, they've got cousins, they've got sisters, they don't have brothers. But how to describe that? Let's start. Okay, so we're going to have to use cousins, sisters, and brothers. It's all about what goes in the signs. So when they need both, the one and the other, that's when we intersection. So that's an N. Okay. But not brothers. So that means we're going to need the complement of B. Okay. Now we don't want everything that is not B. We don't want the 2, for example, or the 8 or the 5. So again, it has to be this and that, not or. Can't be anything else. So again, you put the intersection. Right. There is other ways to write this. You can put brackets in there. This is the most basic, straightforward. Then we get to the probability questions. Question 6, C, part 5. One student is picked at random from 30 students. Find the probability that this student has cousins. So 30 students we're picking out of. How many of them has cousins? So that is everybody that is in the cousin circle. 1 plus 7, 8 plus 8, 16 plus 3 is 19. That's fine. You can write a decimal, write a percentage, just leave it like that. That's good enough. 2 students are picked at random from the students who have cousins. So now things have changed. We're not picking from all the students. We're only picking from this set here, only from here. So how many again? That is 1 plus 7 plus 8 plus 3, 19. So there's only 19 students we are picking from. So now my fraction is out of 19. Okay. Oh, but it's 2 students, not just 1. Okay. Calculate the probability that both these students have brothers. Okay, so first time we pick, there's 19 students in that set. Okay, of those 19, how many has brothers? 3, and this one here. That one's also got a sister, but that's not relevant. So there's 4 of the cousins that has brothers. So probability of picking that first bloke is 4 out of 19. Then we need to pick another one. No, we're not going to pick the same person twice. So we need to think, we only got 18 people left to pick from. And we already picked one that's a brother. So there's 3 people left that's got a brother. Okay. So what do we do with these two fractions? We have to pick the one and the other one. The AND rule stipulates that we multiply. So grab the calculator, multiply them together, and bam, we have an answer, 2 out of 57. Okay, that's good enough. We can leave it just the way it is. Question 6C, part 7. Right, one student is picked at random from the 30 students. Event A, the student has sisters. Event B, the student has cousins but does not have brothers. Explain why event A and B are equally likely. Equally likely means they got the same probability. So let's have a look. So event A, let's see, this student has sisters. So we're referring to everybody that has sisters. So event A, this being maths, let's use the numbers. So the probability of event A, let's write it like that, probability of A happening is in that circle there. Sisters, 2 plus 1 plus 7 plus 5 is 15 people who has sisters. And of course, that was picked from everybody. It's 15 out of 30. Okay. Then probability of event B happening, again, it's going to be out of 30. And this time is people who has cousins but does not have brothers. So we're looking at cousins but not brothers. There we go. 7 plus 8, 15. Okay. You know, that is pretty clear. We've worked out both probabilities and they are the same. So we can just write both events has a probability. Okay, here you go. A half, 15 out of 30, 50%, whatever you want to do. Okay, 50 out of 30. That's it. Because you showed the numbers, and this is math, you will get that 1 mark. That is clear enough. Question 7, algebra. Simplifying here, we have to factorize before we can simplify anything. So first one, x squared minus 25. We got a square number there. We got a square number there. We got a minus in the middle. That makes factorization very easy. Okay, I will try and post a link to an explanation to this in the comment section. Look for it there. So all we need to do, make our 2 brackets, since this is quadratic. Square root x squared is x and x. X times x is x squared. Square root of 25 is 5. 5 times 5 is 25. One of these needs to be negative and the other one positive. Again, below the line, we're going to factorize a quadratic. So it's 2 brackets, x and x. Now, the thing that helps us out here is 99% of the time, 2 of the brackets on the numerator and the denominator will be the same. So we know at least one of these is going to be a 5. Okay. What we're looking for is to multiply together 2 numbers to give us minus 20. So this is going to be either 5 times minus 4 gives us minus 20, or minus 5 times 4, which also gives us minus 20. Okay. When we add them together, though, the 2 terms, we need to get a negative 1. Okay. So if we try the first option there, 5 plus minus 4 will give us 1. The second option there, minus 5 plus 4, that one will give us negative 1. So these are our correct options, minus 5 and 4, because multiplying gives us a negative 20 and adding gives us a negative 1. So now we know that's minus, and over there we got a plus 4. Okay, now we can go ahead and cancel the brackets. So x minus 5 is the same. So we're left with x plus 5. Sorry about that. We're left with x plus 5 and x plus 4. Question 7b. Write things as a single fraction in its simplest form. So let's just get you a very basic example here, right? If I have to add 2/3 and let's say 1/4 together, first we need to get the denominator the same. One way to do this is the smiley face method. We multiply the 3 and the 4 together, which gives us 12. To have similar fractions, to keep things the same, we're going to multiply the 2 there. 2 times 4 is 8, and multiply the 3 there. That gives us 3. So things stay the same, and then we'll have the answer, 8/12. Now, we need to do the same thing, okay? But this time, just with algebra. Okay, I call it the smiley face method. Smiley face there. Right, so first of all, we multiply the two numerators together. That would be x times x minus 1. We don't have to expand this bracket. So later on, we might actually be able to simplify it or not, but we can leave it like that. Top of the line, we need to multiply the x minus 1 with the x plus 5. So we will have two brackets looking like this. And we need to multiply the x with the x plus 8. Okay, and between those terms, just look there, yeah, there's a plus. So we need to put the plus there. Okay. Right, now at the top, we need to simplify things to get it in its simplest form. So first thing, we're going to expand the bracket. X times x is x squared. X times minus 1 is minus 1x. 5 times x is 5x. And x times minus 5 times minus 1 is minus 5. Over here, x times x is x squared. And x times 8 is 8x. Everything there is positive, so that's easy. And as I said before, below the line, we don't have to expand those. Okay, now we just need to look for like terms. We've got the x squared and another x squared. That will give us 2x squared. Negative x plus 5x is 4x, plus 8x gives us 12x. And there's a minus 5. And that's enough. All right, that's what they want. So let's just write that answer on the line. 2x squared plus 12x minus 5x over x minus 1. And you've done it. Question 7c, part 1, differentiation. Here we go. A curve has an equation of 2x cubed minus 4x squared plus 6. Find the derived function. So it would look like this. Deriving a function, we multiply the index, in this case 3, with the coefficient in front. So 3 times 2 is 6. And then you subtract 1 from that 3, you get 2. Next one, 2 times 4 is minus 8. Subtract 1 from that 2, so you get a 1. Okay, you don't have to put that 1. It doesn't harm if you do. The last term, imagine we got x to the power of 0, because anything to the power of 0 is 1. 0 times 6 is 0, and anything times 0 is 0. So when there's just a number, it falls away, and that's our answer. 6x squared minus 8x to the power of 1. Question C, part 2, calculate the gradient of the curve where x is 4. So that's the whole reason we do differentiation, is to work out the gradient. So we want the gradient where x is 4. We substitute that 4 into the x in our derived function. So that will be 6 times 4 squared minus 8 times 4. Speed things up with the calculator. And bang. Very steep gradient of 64. Part 3. Find the coordinates of the two stationary points on the curve. Okay, let's look at that. Look what it looks. That's the curve. Actually, looks like the two stationary points will be these 2 points there. And there you can see that's actually the answers. Okay, what we need to remember is at the stationary points or turning points, if we would draw a tangent, it would be flat. The gradient would be 0, same for over here. So that means when we take our derived function, which we've just worked out, which was, let's write it down, dy over dx equals, what was it, 6x squared minus 8x. That will be equal to the gradient, but at the turning points, they are 0. So we just need to solve this equation. Best thing to do now is to factorize. We can factorize out an x from both sides and a 2 if you want to. So 2x times 3x will give us 6x squared, and 2x times negative 4 will give us 8. There, we have factorized it. Now we can split it up. Each of these parts will be equal to 0. So x equals 0 will be our first coordinate, and the other one, 3x minus 4 equals 0. That means 3x equals 4, and x equals 4 over 3. You can write it as a fraction, as a decimal, 1 1/3, whichever you prefer. Okay. Now, we're almost there. We just need the y values, the y-intercept. So we get that by substituting these x values into our original equation, which was the one they gave to us at the beginning. This one here. Okay, let's write it down. So we're using 2x cubed minus 4x squared plus 6. So first one we're going to do is substitute that x equals 0 in there. So that will be 2 times 0 cubed minus 4 times 0 squared plus 6. Okay, anything 0 cubed is 0 times 2 is 0. So the first two terms amounts to nothing. That means we're only left with that 6. So that gives us the first y value. And then we do the same for the second x coordinate. We now substitute 4 over 3 into that equation. And this time it's better to use our calculator. Better thing here, we're using the fractions rather than decimal values, is it will be more accurate. And I get the answer 98 over 27, which is correct. If you want to write the decimal values, you can, but no need to. This is the most accurate answer. Question 8, they give us a group frequency table. Let's just make sure we understand it. In the table, there's 50 children, and it shows their mass. So there are 3 children that weighs between 0 and 10 kilograms. That must be the youngest. And it goes up to the oldest, heaviest children. There's 2 of them between 40 and 50 kilograms. Okay, they now want us to do a cumulative frequency table, which means we just add up as we go along. So first value there wants us to have all the children that is less than 10 kilograms, and that is 3. The 3 there, we just copy it over. Okay, then we need to write down all the students that is less than 25 kilograms. That means we add now these two together. That will be a total of 22 students. Next, all the students that weighs less than 35. So to that, we need to add the 21, which gives us 43. All the students less than 40 kilograms, add the another 5. That's 48. And then everybody less than 50, add the last two. 50 students weighs less than 50 kilograms, and that adds up nicely to the 50 we have up there. Next point is to draw the graph. Most important thing to remember here is we're using the upper values of the groups. So 10 kilograms, 3 students. Look carefully, each little square counts for 1 student. So that will be our first point. Next one, 25 in the middle there. We're looking at 22 students. So going up 2 squares above. There we go. 35 adds up to 43, 40 and 48 over there, and 50, 50. And when we connect it freehand with a pencil and no ruler, it should look something like that. Okay, if it comes out a bit wonky like mine, always rub it out. And it's easier to do this on a piece of paper than on a screen. Beautiful, looks good. Then it says use your diagram to find an estimate of the number of children with a mass of 32 kilograms or less. Okay, now use your ruler here. Go to 32 kilograms, which is over there. Show the examiner that you are using your graph. Be very accurate. So you draw this line in going up until you meet the graph. Okay, all the way. Oh my goodness, there we go. And then where we meet our graph, we go across. And that's where we read off the value. Mine looks like 39. So that's what I'll write. Let's check. Is that correct? On the mark scheme, anything between 35 to 38. Oh my goodness. I would not have gotten my mark there. Why? I'm not accurate enough. Okay, probably I missed a point there. That could be one of the reasons. Okay, and there. So my point here is you need to be very, very accurate to get these things right. You don't want to lose that mark because you're one value off, like I did just now. Question 8b. I'm doing this one on paper. I don't want to lose any marks like I did with the previous question. It shows us another cumulative frequency diagram with a height of 100 students, and from here we need to draw a box and whisper plot at the bottom. Okay, look carefully, they've beautifully aligned for us the values. Okay, we can start with the whiskers of our box or plot by looking at the maximum and the minimum values. The minimum value is 1.45 meters. That's easy. 0.45 is halfway between 1.4 and 1.5, and we draw a line over there. And 1.83, be careful here. Each square does not count for one value, it's each 2 squares. So that will be, no, it does count for each. Each one does. So 0.81, 82, 83, 84, 85, it does. So we just count 1, 2, 3, and then we draw another line. So those are our whiskers. Okay, next value to find is the median, the middle value. And all we need to do is divide the number of students we have, 100, by 2 to find the middle value. And that would, of course, be 50. So our median will start at 50, but we need to use our graph. So draw a line across and then a line down, which gives us 1.64, but we can just simply continue down here since everything is nicely aligned, and draw a line for the median down there. Oh, couldn't see. There we go. So we just continue our line going down. That's the median. Next one is the lower and the upper quartile. The lower quartile, again, we just half what we had here. So we were at 50, half of 50, 25. Now let's be careful here. Lots of students lost marks in the exam here because they were not careful. That would be 30. So 25 would be halfway between that. That will give us the lower quartile. So we halve the top box. Okay. So we go across. Be as accurate as possible here, going down. That looks like 1.57, and we can continue the line down here. Let's move it there. We continue the line 1.57. That will be the edge of our box. Next value is the upper quartile. So we need to go halfway between 50 and 100. Again, be careful. This is 70. So quartiles means we go 25, 25, 50 plus 25 is 75. This will be our upper quartile at 75. Go across between the boxes and down. And this looks like 1.71. Okay, be as accurate as possible with this. There we go. So just continue your line here, and then it gets dark there. Okay, so to finish the box and whisker plot, the interquartile range between the upper and the lower quartile, that's the box with the median somewhere inside the box, and our whiskers go sideways like this. And bam, you've got your marks. Question 9. Here we go. The diagram shows a prism ABCDEF. They give us dimensions 30 centimeters, 20 centimeters, 24 centimeters, and an angle 90. Calculate the total surface area of the prism. Let's start with the front face. Let's start with this triangle here. Okay. Calculate the area of a triangle. We need to do half base times perpendicular height. Let's see what we got here. There's a half, but we don't have the base. We do have the height. Perpendicular, that's 13. Okay, so we need to find the base there to be able to continue. And for that, we're going to use, of course, Pythagoras. Now, since we have the hypotenuse and another side, we are going to subtract. So that basically means Pythagoras, AC squared equals AB squared plus BC squared, or rather, in our case, since we want BC, square equals AC square minus AB square. In numbers, it looks like this. That square, we're going to square root it. We need to do 20 squared minus 13 squared. Let's hammer that in. 20 squared minus 13 squared. Right, we can write all those digits. More accurate would be to use the root answer. So we don't have to round anything, don't round anything, but we have less digits to write. So 231. Okay. Now we got that, we can work out the area of the front face. So root 231. Be careful that you don't continue the root. So let's go back, press the arrow. 13 equals, okay, there's a good answer. Now remember what's going to happen here. We got the front face, the back face is the same. So in the end, we are going to double this answer again. So instead of halving and doubling, we can just work it out, or we can double it now, and that's it. 197.582894, or just 13 root 231. Right, that's the front and the back face. Let's now go to the rest of the shape. That is 4 rectangles remaining. We know this is root 231. So let's have a look. Let's start with the slanted face over here, and that's a good 20 times 24. So 20 times 24, which gives us 480. Okay. Next, I'm going to do is the left face, the one over here. Goodness. The left face. That will be 13 times this length, which is the same as this one, which is 24. So we're doing 13 times 24. What's 13 times 24? 312. And the last face will be the base of the prism over here, which we've got the length BC and 24. So for this one, it's root 231 times 24, root 231, side arrow times 24. Okay, gives us, what a surprise, root 24 root 231. Okay, now we just need to add up all the faces, this one, that one, that one, and that one. 13 root 231 plus 480 plus 312 plus 24 root 231. 1354.35 rounded to three significant figures. 1350. Question 9b, the volume of the prism. Now, to get the volume, we need to take the area of the front face, this triangle here, and multiply it by the length. Okay, we already worked out the area of the front face over here. If you remember, it was a half root 231 times 13, and then we need to multiply that by 24. So let's start from the beginning. 13 times 24, bam, we got the answer 2370.99, etc. rounded to three significant figures. 2370. Question 9c, calculate the angle that AF makes with the base BCFE. So this is AF and the angle that makes with the base. Now if we draw a diagonal between B and F, we can see the angle they want us to calculate. It's that one there. Okay, which forms part of a right angle triangle here. And in this right angle triangle, we have 13, and that's it. Okay, now remember, this is trigonometry. We're working with right angle triangle, so we're talking about Pythagoras here. But if angles gets involved, it's going to be SOHCAHTOA. Okay, but before we can use SOHCAHTOA, we need more information, because I only have in this triangle the 13 and the angle. I need one more side. So there's two sides we can work. At the base here, there's a right angle. So we can use the square root 231 and 24 to find the length of BF. Or I prefer this one rather. I'm going to use this triangle ACF, which got 24 and 20 and a right angle here, to work out the length of AF. So it's going to look like this. AF is the hypotenuse, so AF squared equals the other two sides, 24 and 20. So that will be 24, my goodness, 24 squared and 20 squared. And instead of doing the square there, I'm going to go straight to square rooting it. So square root 24 squared plus 20 squared equals, okay, and again we can write 31.2409987, but less writing and just as accurate is 4 square root 61. So let's bounce back here. Okay, we got now AF, my goodness, look at that, 4 square root 61. So let's clear things up a little bit. So I'm back to this triangle here where it was before. We now have a right angle triangle of which we have two values. Okay, let's just name them. We're working out this angle, so opposite to that is the 13, and the hypotenuse stays the hypotenuse. So we got O and H. Looking at SOHCAHTOA, O and H means we're going to use sin. So sin, the angle we want to know, which in this case is angle AFB. Okay, angle AFB equals the opposite, which is 13, over the hypotenuse, which we just worked out, for square root 61. So my final calculation, to find the angle AFB, we need to move the sin to the other one side. So sin to the power of -1 over 13 for square root 61. And let's hammer that into our calculator. So shift sin fraction 13 over 4 square root 61, side arrow again, close the bracket, and we got an answer there. So AFB 24.589, rounded to 3 significant figures, 24.6. Question 10. Let's fill out this table. Right, so we want to complete this table, so we need to substitute these values starting with -0.5 into the x values over there. Okay, so on my calculator I just type in the equation that given us 3 plus 4, and instead of the x, in this case we're going to put -0.5. Using brackets is the safest. Okay, again, then bracket -0.5, close bracket, square. Okay, make sure that you square that negative there, which gives us the first value, 3/4 or 0.75, whichever one you prefer. Now we can speed things up since we got our equation already in there, and we can simply delete the values and replace it by the next one, which is 0. So that one is 0, and of course is 3. Then we need to substitute 2 in there, use the arrows, make that a 2, make that a 2, and we got 7. Hopefully by now you'll recognize that it is symmetrical, 7, 6, 6. So we guess the next one could be 3, but always double check. Okay, double check, is it 3? Yep, that is good news. Okay, so what's the next one going to be? 0.75 should be, always check. We just need to add the 0.5, add the 0.5, bang, 3/4, 0.75 it is. Alright, practice using your calculator and getting good at it. Right, now it's plotting the points along the corridor up the stairs. We start with -1, -2 is in the bottom corner right there. -0.5, 0.75, so let's be careful, that is 1, 0.75 will be over there, 0.3 halfway, 1.6, 2.7, 3.6 again, 4.3, 4.5, 0.75, in line with that one, and 4.5 -2, we're back here. Okay, do definitely use a pencil to draw your curve. No need for a ruler here, and do it as accurately as possible. Okay, go through the points. Okay, don't feather, don't draw 2 lines, don't miss any points. Okay, if it looks weird, you know it's wrong. You need to have a good feeling when you're looking at it that you know it's right. Right, now next question. Write down an integer in bold. Integer means a whole number, no decimals, no fractions, whole number, value of k for which the equation 3 plus 4x minus x squared equals k has no solution. So what does it equal to have no solutions? Right, so basically what this means is if you take a ruler, let's take a color, and I were to draw a line through here, which means my equation now, instead of y is equal to 2, I will have two solutions, right? Two solutions since that line crosses the line twice. If I were to draw a line over here, which I assume is y equals 7, now the value of k is 7, I will have one solution because I touched the graph only once. Okay, so anything above 7, I will have no solutions. For example, if I were to draw a line here through the line y equals 8, which I've changed the y to an 8 now, I will have no solution since we're not crossing the line anywhere. And that's it. So my answer to this question is anything above y equals 7. So 8 is a good answer. Looking at the mark scheme, any integer, any whole number, 8 and above. So you can write 9, 10, 11, 12, 3,456,421. They will all be correct. 8 and higher. Right. Next question. By drawing a suitable straight line on the grid, solve the equation. One of the harder questions in the paper. Lots of people got wrong. Okay. We need to use the information we had before to do this question. So let's start with what we got. They give us minus 1 plus 9 over 2 x minus x squared. Now this is still all one question. Okay. We need to use that graph we've just drawn somehow. Let's write the equation of that graph. That graph is 3 plus 4x minus x squared equals to y. Okay. We need to use that graph. How do we get from this equation to the one we have? Let's see. Okay, we're going to have to do what? We're going to have to get from minus 1 to 3. We need to add 4. Now remember, this is an equation. What we do on the left-hand side, we need to do on the right-hand side, so it doesn't change. So if we're going to add 4 to the left, we need to add 4 to the right. How do I get from 9 over 2 to 4x? Remember, 9 over 2 is simply what? That's 4.5. I'm going to have to subtract a half. A half. So 9 over 2x, subtract a half, will give us 4. Okay, don't believe me? Check with your calculator. 9 over 2 minus a half, 4. Bam. What we do on the left-hand side, we need to do on the right-hand side. Okay, minus x squared is the same. Okay, so that's where we're at. We now have minus 1 plus. No, I don't have that more. I've changed it. I've changed it from that to that by subtracting 4, by adding 4 and subtracting 0.5. So that means we can now set these two equations equal to each other. Okay. Now, I already have the graph of 3 plus 4x minus x squared. I just need to draw the graph of 4 minus a half x. And where these two graphs crosses, that will be the solution. That will solve the equation over here. So, good news, we're on the right track. They said we need to draw a straight line and y equals 4 minus 0.5x. That will be a straight line. There are different ways of doing this. For me, the quickest is seeing where it crosses the x and the y axis maybe. So we can see where it crosses the y-axis by making x 0. So y equals 4 minus 0, make x 0. That means y equals 4. So we know that line will cross the y-axis at 4. Okay. Someone making y0 might not. Let's just do that. Let's make y0. So we got y equals 4. If we make y0, we get 0 equals 4 minus a half x. Move the 4 across. Divided by a negative 5. Yep, that didn't work. That may give us 8x equals 8, which does not want to fit on our graph. Okay, so we need to find another way. We need to remember that the general form of a straight line is y equals mx plus c. So y equals mx plus c. In this case, if you rearrange it, it's minus 0.5 x plus 4. So that was our y-intercept. So our gradient is m minus a half. Okay, meaning for every is the rise over the run. We're going down, so meaning we need to go one value down, we need to go 2 across. So if we go from 4 to 3, we need to go from 1 to 2. That is the gradient. So if we were to draw a line like that, and you see we're moving towards x equals 8. That would be a gradient of a half. Okay, be also very careful to see that the x and the y-axis axes has not been labeled the same. So now, where these two graphs crosses, that is where we will find our answer. So the first one is this point over here. What is the x value? 0.2. That is brilliant. And the next value is over here, which we need to look carefully. It's either 4.123, 4.4 or 4.3. I'm going to go with 4.3. And that's how it's done. Looking at the mark scheme, 1 mark only for the correct answer, final answer. The range here is 0.2 to 0.3, and here it's 4.2 to 4.3. So you have to be very accurate when doing this. Good luck. Question 11a. Main thing we need to remember is that the exterior angle of any polygon always equals 360 degrees. So if we want to know what one angle is, we need to divide it by 18. Easy as that. 360 divided by 18, and the answer is 20 sides. Okay, show your working out. That counts 1 mark, and then 20 counts another mark. Question 11b, we are got here is to recognize that we're working with similar triangles. Okay, there's the big triangle, and I'm going to redraw the big triangle over here. Big triangle refers to the triangle A, C, D. The big triangle has got a base there of CD is 6.75, and AD is 5.2 plus 2.6, was that at 7.8. All right, then there's a smaller triangle inside that one. I'm going to draw it separately. The smaller triangle refers to triangle A, B, E. Okay, and in that triangle, we have AE, which is 5.2. Okay, now we know this is similar triangles as all the angles are equal. Angle A is equal to angle A. And because these lines are parallel, angle AED is equal to angle ADC. So these two angles are the same. And ACD let's make this a star, is equal to that one. Okay, so if all the angles in triangles are equal, they are similar. Not the same size, but the ratios of the sides is the same. We need to work out BE. So let's write that down. We want to know what is BE. Okay. The corresponding side to BE over here is 6.75. So if we divide BE by 6.75, the ratios are the same. It would be the same for the other side. We have 5.2 over 7.8. Okay, that's the feature of similar triangles. The ratios of the sides are the same. So meaning if we want to know what's BE, we need to multiply the 6.75 over there. So we got 5.2 times 6.75 divided by 7.8. So we can put that into our calculator. Equal, and we get the answer 9 over 2. Oh, what's that? That's 4.5, isn't it? 4.5 centimeters. Okay, put your correct answer on the line. Question 9C, related to the previous one because we're still talking about similarity. Okay, so we can kind of use the same method before. Okay, but we need to visualize what we got here. We got a smaller solid, so a 3D shape. It could be anything. I'll just make it easy. Let's make it a cuboid. So we got a cuboid. Could be anything. Could be a statue. Anything. It's got a height of 2 centimeters and a volume of 32 centimeters cubed. Then we got a larger solid, which is similar. So basically, it looks exactly the same. It's just bigger. Right. This time, it's got a volume of 780 centimeters cubed. And we don't know what the height is. Right. So the same thing we did before. Because they're similar, the ratios of these values are the same. We're going to start with a height. Let's call the height x. Let's change that to an x. All right, we know what, so we're going to say x centimeters is the height of this bigger shape. The corresponding measurement over there is 2 centimeters. That ratio would be equal to, because I put the bigger solid first, I need to put it again at the top, 780 centimeters cubed over 32 centimeters cubed. Now here comes the difference. The units are not the same. On the left, we got linear centimeters. On the right, we got 3D, right, cubic measurement. These are not the same. This means what we need to do is we need to cube our ratio over here. Okay. Remember, units over here, the centimeters cubed doesn't mean I cubed the 780. It only shows us that the units are cubed. Okay, but here we need to cube the values. So our calculation is going to be something more similar to this. X over 2 cubed equals 780 over 32. This is without the units. Okay, so first thing we want to do is get rid of that cube. So we're going to cube root what we have on the left. We can do that quickly. Shift cube root is there. Fraction 780 over 32. We get that massive answer. Okay. X divided by 2. We need to multiply the 2 on the other side. So we multiply the 2 with what we have there. So over here, we just multiply it by 2 then. And we get this answer here, which is 5.79. And then there's a bunch of 8s. Okay. We can round that to 3 significant figures for our final answer. 5.7. Cut it up there. What comes after 79? 80. Question 11D, we are now talking about congruence. Congruence means triangles, shapes that is exactly the same, whereas similarity means the same shape, the one is just bigger than the other one. Congruence means they're exactly the same. Okay, let's see what they give us. They give us PQ is parallel to RS. So we need to look for those alternate or Z angles or corresponding or co-interior angles. PNS is a straight line, and N is the midpoint of RQ. So that tells us that RN and QN is the same length. Explain giving reasons why triangle PQN is congruent to triangle SRN. So parallel lines, let's use those alternate angles. Immediately I can see here, you see this here, this angle here, PQR equals this angle down here. We got that beautiful Z, very clear. Let's call that angle QRS. Okay, and the reason for this would be alternate angles. So we can write that down, alternate angles. Right, that's all you need. So it looks very clear. Right, what else do we have? We got those two sides the same. That's very easy. Well, Rn equals NQ. Okay, and the reason for that is basically what they've told us. They told N is the midpoint. Midpoint. Right, what else do we have? Well, there's another Z there, QPS and RSP. But I think what's easier here is just to go here. This angle here, PNQ equals this angle here, RNS. I do get these in the right order. The N has to be in the middle there. Okay, and those are opposite angles. To prove congruence, we only need three things. Remember, three things. What was it? Side, 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 right angle, hypotenuse, side, side, angle, side, and in our case we got an angle, a side, and an angle. So you need to say this, thus PQN is congruent to SRN, and the reason is angle, side, angle. Okay, that's it. Right, I've jumped back to this question because reading the examiner's report, there were a lot of marks lost. Students really struggled to get their marks here. And it's important to look at some of the mistakes students make, right? Some of the mistakes is not labeling the angles correctly. For example, where I did here P and Q and R and S, you can't just write angle N. You need to have it correct. You have to have the N in the middle. You can write key and P, but you have to have the N in the middle. You need to label the angles correctly, okay? Then giving the reasons for the angles, right? PQR equals QRS, you can never write Z angles, okay? That helps us to identify it, but you can't give it as a reason. You need to have alternate angles. You need to have that exact, okay? You need to have three reasons correct. Okay, what else have they done on Z? Okay, or writing alternate segment theorem, that will not give you the marks. Alternative, that will not give you the marks. You need to write alternate. Okay, you need to use the correct wording. Okay, in the final conclusion, you need to put angle, side, angle. That counts a mark. You need to have it there. Lots of students lost marks for not doing that. All right, so the message here is you need to be accurate. You need to use the right words to get full marks. You need to study this. Question 12, functions. This can be fun if you get it right. Let's see. First one, find the function of f where x is minus 5. So over here, we simply, they have changed that x over there for a minus 5. So we write the function of f, and instead of x, we put minus 5. So again, that looks like that. 3 minus 2 times minus 5. Okay, what's that? That's minus 10 plus 10, 13. Okay, don't get yourself confused here. Use a calculator. if to avoid silly mistakes. All right, two negatives makes a positive. You just hammer in your calculator, you won't lose that mark. Many people lose a mark because they try to do it in their head too quickly. Right, next one, find the function of f. Give your answer in its simplest form. That means we need to write down the function of f, which is 3 minus 2x. But then instead of the x, we need to put the function of f again. So let's take the x away. And where the x is, we put 3 minus 2x again. That's the function of the function. So you write down the function of x, and then you put it into the function. Okay, so now expanding brackets. Minus 2 times 3 is minus 6. Minus 2 times minus 2x gives me a positive 4x. And 3 minus 6 is negative 3 plus 4x. That's the right answer. You can write it like that, but if you want to make it look pretty, you swap it around. Both is correct. Right, going well. See, told you it's fun. Question 12c, solve the function g equals the function f plus 37. So let's start writing down the function of g is x squared plus 5. That equals the function of f, which is 3 minus 2x. And don't lose that plus 37 at the back. Okay, now we need to start doing our algebra here. So we need to solve this, meaning we want to see where this graph will cross the x-axis. That's what x equals meaning. Check, there's two answers, so it's probably a quadratic graph, a parabola, like this, or upside down, and it crosses the x-axis in two places. So let's rearrange stuff. Let's leave the x squared where it is. Let's deal with this 3 plus 37. This is not 3 minus 37. That minus is part of the 2x. So 3 plus 37 is 40. And the minus goes with the 2x. Now we're going to throw everything to the left-hand side. So we got x squared. Okay, I'm throwing the minus 2x there, so that's plus 2x. Okay, throw the 40 over, that becomes minus 40. Don't forget the 5 is still there, plus 5. Don't lose any terms. That's equal to 0. So simplifying that, x squared, 2x minus 40 plus 5 is minus 35 equals 0. Right, so now clearly we've got a quadratic equation. Next step, solving it, is factorizing. We can make two brackets. You can use the quadratic formula. You can complete the square if you want. But first, let's see if factorizing is possible. We want to think of two numbers. We multiply together to give me minus 35. So let's have a look at it. Comes to mind is 7 and 5, of course. That gives us 35. But that's a negative 35. So one of them needs to be negative. Let's see, minus 7 is minus 35. Or it could be the other way around. 7 times minus 5 is also minus 35. Okay, now when we add these two values together, we'll get the middle term, plus 2x. So if we do minus 7 plus 5, that gives us minus 2. No, that doesn't work. The first one is wrong. If we do 7 plus minus 5, which is 7 minus 5, that gives us a positive 2. So yes, that's what we're looking for. So what we got here is we got a positive 7 and a negative 5. Okay, if you expand those brackets, check it. Yes, x times x is x squared. 7 times minus 5 is minus 35. X times minus 5 is minus 5x. 7 times x is 7x. 7x minus 5x plus 2x. We know it's right. So to solve this, we set each side equal to 0. That means x equals negative 7. And x minus 5 equals 0. That means x equals 5. So a parabola that crosses the x-axis is minus 7 and 5. We have our two correct answers. Question D. Things are starting to heat up. The inverse function of f. So again, there's two ways of doing this, right? This does not mean the inverse, f to the power 1, that you got the function of f over 1. Okay, don't do that. That's a mistake. People did that. That's wrong. Okay, it means we need to work backwards. Okay, I'm going to show you two ways to do this. All right, if we take x in this function, let me write it down. So the function of x was 3 minus 2x. If we start with x, what's the first thing that happens to it? It gets multiplied with a negative 2. That's why you got negative 2x. And then we're adding 3, because that's a positive 3. So you got minus 2x plus 3, or 3 minus 2x. Inverse means we do this backwards. Okay, that means we start with x, and we do the opposite of plus 3 is minus 3. So that will give us x minus 3. So we have x minus 3, right? And then we do the opposite of times by negative 2. Opposite of times is divide. Okay, so the negative 2 stays the negative 2. So we divide it by negative 2. So we end up with x minus 3 divided by negative 2. Okay, that's the correct answer. Okay, another way to do this would be to set it equal to y and rearrange to make x the subject. So that means we do y minus 3 equals negative 2x, then divide. The important part, if you do it this way, is to remember then to change the y back to an x. Okay, on the mark scheme, they've just divided the negative into the top. All right, so my belief, this will be correct. It'll get you your marks, but if you want to divide the negative to the top term, you get minus x plus 3 equals 2. You basically just change the signs, which if you rearrange it is 3 minus x over 2. That's what they have on the mark scheme. But because it says or equivalent, the other answers is correct as well. Question E. Now this is the 5-mark A-star question. Right, very few students got this one right, or very few students got full marks. Okay, but you can still pick up marks here. Right, let's start with the function of f into the function of h. So what does that mean? We need to write the function of h. Where is that? Function h. X cubed. Okay, so x cubed. And into that, we need to put the function of f. Remember, I've got the function of f here. So instead of the x, I now change the x for everything that is the function of f. Okay. Then we put the function of g up there. What was it? X squared plus 5. Okay. Right, and now the party starts. We now need to simplify it. Okay, you only got 1 mark there. Let's start the party. So what does 3 minus 2x cubed mean? It doesn't mean 3 cubed and minus 2x cubed. It means we got 3 brackets. 3 minus 2x, 3 minus 2x, 3 minus 2x, plus x squared plus 5. Okay, let's take it slow. Get this right. I'm going to first expand the first 2 brackets. 3 times 3 is 9, and 3 times minus 2x is minus 6x. Minus 2x times 3 is minus 6x, and minus 2x times minus 2x, 2 negatives makes it positive. 2 times 2 is 4, x times x is x squared. We still have another 3 minus 2x, and then hanging up at the back is the x plus 5. Don't lose it. We can simplify that first bracket we did. So that would go as 9 minus 6 minus 6x is not positive. We're not multiplying. We're simply moving up and down the number line. That will be negative 12x plus 4x squared. And we still have that bracket. And don't be lazy. Don't use the x squared plus 5. Now we're expanding the next bracket. We need to multiply everything in the first bracket, everything in the second bracket. We start with a 9. 9 times 3, 27. 9 times minus 2x is minus 8, minus 18x. Next, the minus 12x. Minus 12x times 3, minus 36x. x, and then minus 12x times minus 2. Two negatives makes it positive. 12 times 2 is 24. X times x is x squared. We're doing well. We're doing well. Right. Last term there, 4x squared times 3. 4 times 3 is 12. X squared stays x squared. Then 4x squared times minus 2x squared. Positive and a negative gives us a negative. 4 times 2 is 8. X squared times x is x cubed. All right, we don't need to put brackets anymore, but don't lose the x squared plus 5 there. Still there, hanging around, waiting for action. Good. We're getting there. Now it's just simplifying like terms. Okay, let's put some color into this. So let's start with the highest power we have, minus 8x cubed. There is no other cube, so that one's by itself. Let's run yellow. Let's load now all the x squares. We got 24x squared, 12x squared, and another 1x squared. So we can add them all together. 24 plus 12, 36 plus another one, 37 x squared. Let's go for green. Now all the terms with an x. It seems there's only two of those. Minus 18, minus 36. Again, this is not two negatives, makes a positive. We're just moving down the number line. That would have minus 54x. Okay. And don't forget about this 5. It's been waiting all day. And this 27 that we can add together. That is 33. Okay. No. You see what happens when you get tired. It's 32. You get all the difficult things right, and you get the easy ones wrong. Right, whichever way you want to write this. Lots of mathematicians likes to write them descending order from the highest power to the lowest. On your mark scheme, they've decided to write it the opposite way because they don't want to have a negative at the front, but it doesn't matter. Okay, if you got each term correctly, the order is not that important. You have to have a negative 8x cubed, positive 37x squared, negative 54x, and a positive 32. You can do it.